Welcome back. Here's today's challenge. We want to solve the equation x minus 3 all cubed plus x minus 7 all cubed equals 2x minus 10 all cubed. At first glance, this looks like the kind of problem that invites a lot of expansion. 3 cubes, plenty of algebra, plenty of opportunities to make a mistake. But before we expand anything, pause for a moment. What do you notice? Don't look at the exponents yet. Look inside the brackets. The first expression is x minus 3. The second is x minus 7. And the third is 2x minus 10. Do those seem completely unrelated? Or could there be a hidden connection? Here's a strategy mathematicians often use. If several expressions keep appearing together, it can help to give them simpler names. So let's let a equal x minus 3. And let b equal x minus 7. Now something interesting happens. What is a plus b? Well, x minus 3 plus x minus 7 simplifies to 2x minus 10. That means the expression on the right-hand side isn't new at all. It's simply a plus b. That's the key observation. Instead of wrestling with the original equation, we can rewrite it as a cubed plus b cubed equals a plus b all cubed. Doesn't that already feel much friendlier? Now think back to the binomial expansion. A plus b all cubed expands to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's substitute that expansion into our equation. We now have a cubed plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. Now compare the two sides carefully. A cubed appears on both sides, so we subtract a cubed from each side. B cubed also appears on both sides. Subtract that as well. Everything that looked complicated suddenly disappears. We're left with 0 equals 3a squared b plus 3ab squared. Can you see the common factor? Both terms contain 3. Both contain a, and both contain b. So we factor them out. That gives us 0 equals 3ab multiplied by a plus b. This is the breakthrough. We've transformed a cubic equation into a simple product equal to 0. And whenever a product equals 0, the zero product rule tells us exactly what to do. At least one of the factors must be 0. The constant 3 can never be 0. So only 3 possibilities remain. Either a equals 0, or b equals 0, or a plus b equals 0. Instead of solving one difficult equation, we now have 3 very easy ones. Let's translate each of them back into x. Let's solve them one at a time. First, suppose a equals 0. Remember that a represents x minus 3. So x minus 3 equals 0. Adding 3 to both sides gives x equals 3. That's our first candidate solution. Now suppose b equals 0. Since b represents x minus 7, we have x minus 7 equals 0. Adding 7 to both sides gives x equals 7. That's our second candidate. One possibility remains. Suppose a plus b equals 0. Replacing a and b with their original expressions gives x minus 3 plus x minus 7 equals 0. Now combine like terms. 2x minus 10 equals 0. Add 10 to both sides. 2x equals 10. Now divide both sides by 2. And we obtain x equals 5. So our 3 candidate solutions are 3, 5, and 7. But we're not finished yet. In mathematics, a candidate solution isn't automatically a correct solution. Every answer must be checked in the original equation. Let's begin with x equals 3. Substituting 3 gives 0 cubed plus negative 4 cubed equals negative 4 cubed. The left side is 0 minus 64. The right side is also negative 64. Both sides agree. So x equals 3 is verified. Now let's check x equals 5. We obtain 2 cubed plus negative 2 cubed equals 0 cubed. That's 8 minus 8, which is 0. The right-hand side is also 0, another perfect match. Now for x equals 7. Substituting gives 4 cubed plus 0 cubed equals 4 cubed. The left side is 64. The right side is also 64. Once again, both sides are equal. All three candidates pass the verification. So the complete solution set is x equals 3, 5, and 7. Now here's a challenge for you. Can you solve x minus 2 all cubed plus x minus 8 all cubed equals 2x minus 10 all cubed using exactly the same idea? Pause the video and see if you can find all the solutions before checking the comments. Remember, mathematics isn't about memorizing tricks. It's about discovering patterns. Keep exploring, keep asking why, and I'll see you in the next lesson.